Today we continue to study how to find the limits. I begin with some problems we discussed last time already. Let's do some exercise first. Find the limit as x approaches 2, and here's x squared minus 2x plus 3. Okay, so this is a polynomial. Okay, this is a polynomial, and it's a nice function, right? So how do you find the limit of this function where as x approaches 2? Well, this is a polynomial. So it's obvious when x approaches 2, x squared approaches 2 squared, right? And 2x approaches 2 times 2. So I can just write down the limit directly, okay? So actually this is a value of the function. So that is going to be 1. Now in general, okay, if f of x is an elementary function. Elementary function is a combination of several well-known functions. Elementary functions like sin x, cosine, square root x, right? And a is the interior number in the domain, inside the domain. So that means it's not just it is not an endpoint of the domain. Okay, then that means this is a domain. So a is inside here. So on both sides of a, there are numbers in the domain. Right? Then the limit as x approaches a of the function is just the variable function. All I have to do is just plug the number for x into the formula. Now, what happens if a is going to be the end point of the interval? In that case, okay. So if a is the end point, okay, or we have of the domain. Okay. For example, this can be left endpoint or the right endpoint. Okay, so that could be left endpoint, could be right endpoint. So I just say endpoint. Okay, then you can only talk about one side limit. Okay, then you still equal. It is still equal to the value function. This could be right endpoint. But if a is left endpoint, then this will be right hand limit. X approaches a from the right hand side. Okay, in this case, or depends. So it depends on the location of the endpoint. Right. So in this case, a is a right endpoint, and then x approaches it from the left side. Okay. And in this case, a is the left endpoint of the domain. Okay. All right. So let's take a look at the example. Find the limit as x approaches 2 square x minus 2. Okay. You cannot just write like that, okay? Because x approaches 2 means x approaches from both sides. So you can only say that the right-hand limit as x approaches 2 from right-hand side. What is the limit of x minus 2? Okay, so yeah, this makes sense. X minus 2. X minus 2 is going to be positive if x approaches 2 from right hand side. So x approaches 2 from right hand side means x approaches 2 and x is greater than 2. Okay? So it means two things. So this really implies it's the same. This is x minus 2 approaches 0. So this implies x minus 2 greater than 0. It's greater than 0 approaches 0. So this implies square x minus 2 is defined and it approaches square root 0, which is going to be 0. Okay? So the answer will be is going to be 0. Okay? So this is just the value. This is the value of the function at 2 when x equals 2. Okay. Okay. So now let's limit as x approaches 2 square root of x squared plus 1 and 2x minus 3. Okay. This is going to be an elementary function. As long as you can express it in details like that, using radicals, using square, and then this elementary function. Now, what is domain? The domain of this function is going to be the first of all, 2x minus cannot be 0, right? And then x squared plus 1 over 2x minus 3 should be greater than 0. Greater than equal to 0. I think the numerator never be negative. Great. It's always positive. Only the problem is, is from the denominator. So this inequality, it's equivalent to 2x minus 3. Okay? So this implies x greater than 0 2. And x cannot be 3 over 2. X cannot be 3 over 2. So this is going to be 3 over 2 has infinity. This is going to be the domain of the function. However, 2 is inside the domain. 2 is the interior point. Okay, right? 2 is the interior point. 2 is inside 3 over 2 from 3 over 2 plus infinity. So therefore, the limit as x approaches 2, here x squared over 2x minus 3, you just need to plug 2 for x into the expression. Okay, so that is going to be square root of 5. Okay, so the limit is square root of 5. Okay, so next part, find the limit x approach 2 and x squared minus 2 x cubed x cubed minus 2x plus 5 and then square. Okay, this is very complicated, right? So let's see what is the domain of this function. I think it's we just needed to exclude the zeros for the denominator, right? So anyway, note that when x equals 2, 2 minus 2 times 2 plus 5, which is 8 minus 4 plus 5, which is going to be 9. It's not going to be 0. So that means I don't need to find the domain of the function, but I know 2 is inside the domain. Yeah, 2 is inside the domain. 2 is inside the domain. Okay, 2 is inside the domain. Okay, so if you're inside the domain, after this elementary function, then just plug 2 for x, get the limit. Okay. So the limit is going to be 2 squared minus 2, 2 cubed minus 2 times 2 plus 5 and square. Okay, so the numerator is going to be 2. The denominator, we already calculated that, it's going to be 9. That's 4 of 81. So this is going to be the limit. Okay, now let's do a slightly different problem. We're trying to find the limit as x approaches 2, x squared plus x minus 6 over x minus 2. Okay. Well, the domain of this function is going to be x minus 2 is not equal to 0. So actually it's from negative 3 to 2 and positive 2 to 3. Now 2 is the 2 is the end point. Right? So you cannot talk no 3 even not is the end point. It's not it's 3 is not included in the okay. So how do you find the limit of this function? So notice that 2 is not in the domain. Of course, it's not inside the domain. So I cannot just plug 2 for x to get the limit. Okay, actually the value of function is not defined. So that's 2. Okay, how do you do that? Well, when you plug 2 for x, you notice that numerator and denominator both are 0. Okay, you do that 2 squared plus 2 minus 6 is going to be 0. 2 minus 2 is going to be 0. So it's going to be 0 over 0. So you cannot just plug 2 for x to evaluate the function in order to get the limit. What I'm going to do is I'm going to simplify this expression. Okay? The numerator is going to be x minus 3 or plus 3 x minus 2. All right. After you factor the polynomial and the numerator, you see x minus 3 is cancelled out. It will be x plus 3. So this complicated expression is equal to a very simple expression when x is not equal. But so clearly this is going to be when x approaches 2, this is just approach 2 plus 3, which is 5, as x approaches 2. So the limit is going to be the limit, you can write it like this, x plus 3, which is going to be 2 plus 3 is 5. All right. Let's do the next problem. Well, first, let's plug 4 for x into the numerator. If you plug 4 for x into the numerator, it will be 4 squared minus 4 minus 12, 16 minus 4 minus 12, that's going to be 0. Okay, so 4 is now in the domain of the function. But this time the numerator is going to be 4 squared plus 3 times 4, now 0. So imagine when x approaches 2, the denominator approaches 0. Okay. Right? So I'm going to simplify it a little bit. Okay, it's going to be x minus 4, x plus 3. So the term really causes trouble is x minus 4. Okay, I can simply write x squared plus 3x, x plus 3 times x minus 4. So actually I can simplify further. X squared plus 3x is going to be x plus 3 times x. So that is going to be x. Okay. Even you cannot simplify, that's fine. So what you get here is as x approaches 4. Okay. So it approaches 4 over, whoa, okay, over 0, right? So I have to put a question mark in there. So it's infinity or positive, negative infinity. It's not clear. But I think you can get, if it's approaches x approaches 4 from positive side, then you get 4 minus 4 is going to be always positive, infinity. But if it's approaches 4 from negative side, okay, then that is going to be negative. That's negative infinity. So the two-sided limit does not match. What really that means is you have the graph here, that's 4. So let's schedule the graph. I think of the graph looks like that. So look at this graph, right? When x approaches 4 from either side, Yeah, when x from either side, then you will see that it's dispersed, right? Not only dispersed, it's dropped. It goes to when x approaches 4 from the right hand side, it goes to infinity, positive infinity. From left hand side, it approaches negative infinity. So clearly, you cannot say the limit exists here. When x square plus 3x and x plus 3 and x minus 4, right? And that is going to be the limit doesn't exist. Does not exist. Even cannot say positive infinity or negative infinity. Because when x approaches 4 from either side, either very positive, very negative, so we stop. The next problem is find the limit as h approaches 0. When you plug 0 for h in the numerator, you got 0. So you think about this problem, okay? How do you simplify? The formula we need is a plus q plus q plus 3a square b plus 3ab square plus b cube. So 2 plus 8 cube minus 8 divided by 8 is going to be 2 cube plus 3 square 8 plus 3 2x square plus 8 cube minus 8. So now the numerator contains 8. Every term contains 8. So if we take 8 out, this is going to be 12 plus 6 h plus square. Then h is cancelled out. 12 plus h plus h square. And then clearly when h approaches 0, okay, this will be 12 plus 6 times 0 plus 0 square is 12. So we got this result. All right, I'm going to ask you to the next problem. As t approaches 1, what is the limit of this function? But clearly when you plug 1 for t into the numerator and denominator, both are 0. So both are 0. All right. You probably need another formula, algebra formula, in order to simplify this. Formula used is a minus q is a minus b and a square plus ab plus b square. Okay. Yeah, please go ahead. Complete. Are you able to simplify? T to the 4 minus 1, T minus, okay. Let's back to the new denominator. T minus 1, T plus T. Okay. How about the denominator? Or how about the numerator? T to the 4th can be viewed as T squared. Right? And the square. So you will get T squared minus 1 and then T squared plus 1. But T squared minus 1 can factor as T minus 1 and T plus 1 and T squared plus 1. So we're going to get the same factor, T minus 1. Okay. It looks more complicated, but if you plug 1 for T into function, then you're going to get a number, okay? So clearly when T approaches 1, you get 1 plus 1, 1 squared plus 1, and the 1 squared plus 1, right? So the top one is 4, bottom is 3. So 4 over 3 is going to be the limit. Okay, did you get this? The next one, u approaches 2 and square 4u plus 1 minus 3 and u minus 2. Okay, I give you 1 minute to think about it. Okay. Clearly, when you plug 2 for u, the denominator is 0. So 2 is not in the domain. So you are not able to find the limit by evaluating the function of that number. Okay, you cannot do that because 2 is not inside the domain of this expression. But when you plug 2 for u, you get 4, 2 plus 1 is 3. Here is 2 minus 2. You will see it will be 0, right? But on the top, it's going to square it off. That's going to be 0. It's a 0 over 0. Okay. So I'm pretty sure both the numerator and the denominator contains a factor of x minus 2. Okay. So how can I get rid of the factor of x minus u minus 2? So the standard method is you're going to square. In order to square it, you have to multiply it by its conjugate. Right, so x minus 2, so 4u plus 1 plus, okay? So now the numerator is is going to be 4u plus 1 minus 3 squared. Okay. So 4u plus 1 minus, it is going to be, the numerator is going to be 4u minus 2. Okay, so u minus 2 is it up. Now you simplify 2. Now, if you want to find the limit as you approach 2 from either side, then you just need to plug 2 for u into the form. The final answer would be 3 plus 4 or 6. Right, so now you have a brand new problem. The limit as t approaches 0, 1 over t minus t squared plus t. Wow. Again, I'm going to give you 1 minute to think about the ideas, possible ideas. Yeah. How do you simplify? Right, are you done? I give enough time to work out this problem. Now, here is the difference of 2 terms, right? When you plug 0 for t into those terms, here you want to find right? 1 over 0 is not different. So now let's combine it. So it's simple. It will be t. And parentheses is the plus t, yeah, is plus 1. So it's about, it's going to be 1 over t plus 1. Okay? And after simplifying it, right, so if you left t equal to 0, then this clearly would be the best one. Okay, so you can write down the limit. The limit t approaches 0, t minus t squared t is going to be. All right, so let's look at this. Again, very similar to the previous problem. When you plug 0 for h, get 0 in the denominator. So you have to simplify the function as much as possible. Okay. So let's work on the as a numerator. Okay. So we combine them. Here's x squared plus h squared, and here's h. Right. So actually this is going to be x plus h square x squared, then h. The numerator here is negative 2xh minus h squared. And there's a factor h there. You take x out. 2x plus 8 so this h will be cancelled. Okay. So now it's clear that as h approaches 0, the numerator approaches 2x, here's x squared, and x squared, so the answer will be 2 over x cubed. Okay, so this is going to be the limit of the function. So this is a limit. Let's rewrite the limit here, h 1 over x plus h squared minus 1 x squared is going to be 2 over x2. There's a useful term called squeeze. It's called it's squeeze term. I want to talk about it. The squeeze theorem says that if f of x less than g of x less than hx, okay, and when x approaches a accepting possibility, okay, this holds, and x when x is near and the limit as x approaches a of f of x is going to be the limit as x approaches a. If those two limits are equal, then the limit of g of x is the same. Okay, it's also equal. No, this is called the squeeze theorem because look at the picture here. Okay, so this approaches L. This also approaches L. So that forces the middle one approaches L. Okay. Yeah, this will be the special case is going to be like that. Observe x is less than equal to g of x, and the limit x approaches a. This is going to be 0. Then the limit as x approaches a, f of x. This is going to be this is going to be 0. That's a special case, okay? The reason it's a special case is absolute of x of x less than g of x same as negative g of x so both approaches 0, then that forces the middle one approaches 0. That forces. Alright. So let's apply this term to some x's. Okay. So here, find the limit as x approaches 0 and x squared sine 1 of x. It's harder to tell the value of sine 1 of x as x approaches 0. As x approaches 0, 1 of x approaches, it has no limit, okay? This one has no limit. Okay, no limit. So the limit does not exist. Why? Can you explain to me why limit of 1 of x does not exist if x when x approaches 0? But the right hand limit is going to be positive infinity. Maybe this also explains to you. When x approaches 0 from negative side, it's going to be negative infinity. But how can I find the limit of x squared times phi of 1 of x? Okay. We observe that absolute x sine 1 of x is going to be less than absolute x squared sine 1 of x. Okay. 1 of x is smaller than 1. Now, let me write this in code. This x squared sine 1 of x less than absolute x squared. So it's clear this approaches 0 as x approaches 0. Does it forces the term inside approaches 0 too? Yes. Okay. So if you then the limit as x approaches 0, this is going to be 0. Okay, this is going to be 0. Clear, right? If I want to give you a little bit more details, how do I apply the fixed square theorem to solve this problem? According to the above, it can be less than equal to x squared, greater than equal to negative x squared. Okay, and clearly both approach to 0 as x approach to 0. So therefore, we get conclusion okay. Here's another problem. Uh, find the limit of the following: x to the fourth cosine 2 of x Do you have any idea about this? Well, when x approaches 0, 2 of x, well, is a get a positive, get a larger is positive, but it could be also negative, right? But x to the fourth pi is a very strong number. Okay, so x to the fourth cosine 2 of x is going to be less than or equal to x. All right, so clearly this approaches 0, therefore forces let's try another one. Now, to solve this problem, you have to remove the absolute value system. Okay, please go ahead and try and find it. Find the limit. Okay, how do you do this? How do we do this problem? X approaches negative 2. Okay. So notice that x approaches negative 2 when x is getting close to negative 2. I think x value will be negative. Okay. So this implies it's negative, right? So 2 minus 2 plus x is going to be 2 minus negative x and 2 plus x. It's always equal 1. Okay, so therefore the limit is always equal to 1 because it's constant. Next one. Are you able to figure out how to do it? I give you 1 minute. All right, let me connect with it. All right, so x equals 0 means after equals 0, x is positive is x equals 0 and x is positive. Right? Since x is positive, absolute x is equal to x. Therefore, it's given of x minus of x, which is always equal to 0. So therefore, the limit is approaches 0 is always. Okay, let's try another one. Step away, you have to get rid of that symbol. Okay. Now, x approaches 2 from negative side. It means 2, but x is less than 2. Okay. So, in other words, x minus 2 is negative, and x minus 2 approaches 0. Okay. So, since x minus 2 is negative, so you get, if you want to get a bit very simple, you have to put a negative sign in front. Okay. So then x squared plus x minus 6, x minus 2 minus 2, x minus 2. No, other 2. No, minus 2. So this cancels out. You get negative plus 3. Okay. And then it's clear that limit s approach from negative to plus 3. Right. So let's still see the piecewise different function. Okay. So we want to find the limit as x approaches 1 from positive side, perfect, and also want to find the limit from negative side. Let's do this because it's piecewise. So all you have to do is you can replace fx by this piece, right? What is that? X is greater than 1. So you should x minus 2 squared here. And then the answer will be 1 minus 2 squared. Okay. How about the other one? That will be x squared plus 1. Then it will be 1 squared plus 1. So from just two-sided limits, you can see that the limit of x approaches 1, this one has value. Okay? Okay, let's look at some strange problem. If x approaches 1, f of x minus 8, x minus 1 of 10. Find the limit as x approaches 1. So clearly, yeah, how do we solve this problem? Right, have you any ideas? What is the possible value for this? Right, you can just look at this, right? X approaches 1, so the denominator approaches 0. If the numerator approaches non-zero number, yeah, I can roughly speaking get like this: minus f of x minus 8 x minus 1 is almost equal to 10, right? As x is close to 1. So f of x minus 8 is almost equal to this. Then f equals nx minus 1 plus 8. So it's clear that to me, the limit as x approaches 1 is just going to be 1 for x equals 0. So did you get this right? So that's the limit. Okay. I stop here for this section. I think I discussed almost all the problems. Okay. So when you have a time, go over this problem we're discussing in class, and the majority of homework problems are similar to those we discussed in class already.